Good morning. Thank you all for being here. Today I'm going to talk about fawn survival and recruitment in South Texas, and I'm going to draw from several studies that we've conducted across the whitetails range to try to better understand how things are operating here in South Texas. And to begin, why are we thinking about fawn survival and recruitment? Well, if you look at this incredibly busy figure, this is actually a tool that a graduate student put together for some managers we were working with to better understand how adult survival, fecundity, or litter size, and fawn survival interact to ultimately impact growth rates in the population or our lambda value. And what you see here is the green colors are population values over 1, which means the population is growing. And the values in the warm colors are declining populations. Those are values less than 1 for a lambda value, meaning a declining population. And the way this tool works is one can look at a given fecundity rate. So if you have a litter size on average of 1 and an adult survival rate of 0.8, you would need a fawn survival rate of 0.6 or so to maintain a green color or a growing population. And the point of me walking through all this is to demonstrate that all three of these processes are incredibly important to population growth rates. Two of which, fawn survival and fecundity, are ultimately the focus of today's conversation and the things that we can do to manipulate these processes to achieve our management objectives. So what drives fawn recruitment? This is a question I've been chasing for years across many different systems. And now I'm going to share a few of the lessons that we've learned and think about how these lessons might apply here in South Texas. So we started studying coyotes and whitetail deer interactions in the South Georgia longleaf pine ecosystem around 12 years ago or so. And what we found was coyotes were a relatively new addition to the faunal communities of South Georgia, and we're taking a fairly large portion of the fawn crop every year. And managers were struggling to try to figure out exactly how to integrate this new source of mortality into their harvest models. And so we monitored fawn survival and demonstrated the cause of death was typically coyotes. In fact, they were killing 5 times as many fawns as were bobcats in this system. We also did some other work trying to better understand how coyotes were influencing the behavior of whitetail deer in the system. So to do this, we experimentally manipulated the distribution of predators using woven wire fence and hot wire. And so we basically randomly selected 4 of these 8 sites that are about 100 acres in size, and all were completely surrounded by a dirt road. The 4 sites that were selected to have predator exclusion plots put in received this 4-foot woven wire fence with 3 strands of hot wire. After the fences were completely built, we ran a prescribed fire through that block to remove whatever remaining animals were there and then turn the fences on. And over the years, about 18 years now, excuse me, that we've been doing this experiment, we've learned a lot about how predators influence deer behavior. We've learned that deer spend more time vigilant when in the presence of predators and less time foraging. They alter their diel activity patterns. They even modify their interactions within different demographic groups of the deer population. So bucks and does and bucks and fawns interact in different ways within these exclusion plots. So we've learned that deer modify their behavior in profound ways in the presence of predators to mitigate those predation risk effects. We also studied fawn survival following the Louisiana black bear reintroduction in the Tensas River National Wildlife Refuge. So after about 10 years of reintroductions and restoration effort for black bears, managers were incrementally reducing the harvest opportunity on this refuge. And this is alluvial soils of the Louisiana floodplain or the Mississippi River floodplain that are incredibly rich and productive for whitetail deer. Litter sizes are high and fawn survival rates were very low, but there was a stable population at the time that we were studying this herd. However, that population was stable because managers had reduced the harvest rate so substantially over the time following the restoration of black bears. But more importantly, we also began to understand the importance of landscape configuration on processes like fawn survival. So here we demonstrated that the proximity of the capture location where the fawn lives to agricultural fields was a strong predictor of the probability of survival for that fawn. So the closer they were to ag fields, the more likely they were to die, likely because there were more predators associated with those fields. So landscape configuration can be really important when thinking about fawn survival and recruitment. We've also been studying fawn survival in the Appalachian Mountains in Western Virginia. And here we also have a situation where bears are the predominant source of mortality, but there's also a landscape configuration issue here as well. So animals that spend more time higher on the mountain and less time in the rich cove soils or in the fields and the valleys below have lower probabilities of surviving. There's also a lot more bears on top of the mountains. So we're trying to disentangle these two factors to better understand how nutrition and predation influence the probability of a doe pulling off a fawn in this Appalachian landscape. It's also very interesting because we're starting to better understand how forest disturbance, such as fire or timber harvest, influence predators and prey. So in this system, we had black bears, bobcats, and coyotes also collared, and saw that they all responded positively to fires and timber cuts, which may bring the predator and prey into close proximity, even though we think of these things as habitat improvements for deer. We also studied fawn survival on Marine Corps Base Quantico for about 10 years. And what we found here was a really remarkable finding in my mind. So this is a system along the eastern United States, along the James River, where the soils are productive. It's a mixed deciduous forest primarily. And we found that the one thing that was most important for driving fawn survival was the acorn crop the fall before the fawn survival. So a maternal resource only available in early gestation was strongly correlated to survival of fawns. And what this suggests to us is that the doe's nutritional condition is an important predictor and defines the defenses that the doe can mount for avoiding predation. And so in this system, if you have more acorns, you're in better nutritional condition, you can take fewer risks. You're more risk averse when foraging and put your fawn in less precarious situation. The probability of survival increases. To my knowledge, this is one of the first studies to ever demonstrate a maternal investment only available before the life of the fawn was a strong predictor of that fawn's survival. And again, acorns are incredibly high in digestible energy, and that can be an important nutrient in the winter. And we found a very strong relationship where the hazard ratio greatly decreases as the red oak mast abundance index increases on the site. We've also studied fawn survival in the swamps of South Florida following the restoration of the Florida panther. And in this system is characterized by distinct wet and dry seasons that can be quite variable across years. And what we found was, well, let me back up a little bit and explain this really busy figure. So we started our study in 2015 and ran it for about 4 years. And what you see is the winter dry season and the summer wet season across these months on this figure. Now, the fawning season in this system occurs in February to align with the driest time so that the fawns can be born on dry ground. And the colors that you see in this figure represent the level of wetness or flood conditions and how different cover types will be flooded at different levels. And so what we were, I guess, fortunate to observe was when we started the study, it was a relatively dry and droughty dry season. But the second year was a super El Nino, as you can see in 2016, this incredibly wet dry season. And this is what it looked like on the landscape. This is the same camera trap during the fawning season for 2 different years. Incredibly different fawning conditions. And when we modeled that fawn survival process, we found that there were almost 30% higher fawn survival probability during the dry season, during the drier year than the wetter year. And what did that ultimately look like for recruits? Well, you can see in this figure, the number of fawns that we were detecting increased rapidly when fawns were being born, but start to decline when more fawns are dying than are being born, and ultimately stabilize into what we're considering our recruits that are living at least 180 days. We had many, many fewer recruits during the wet year than the dry year. Now in South Texas, this is another system that's incredibly dynamic in terms of wet and dry years. And in this, obviously, the inverse is true that in wet years, you can have abundant forage and concealment cover that enhances fawn survival. While in dry years, you can have a limitation in both the nutrition for the does to lactate, but also for concealment cover for fawns to hide from their predators. And so, as we think about some of these things and try to understand what the drivers may be, we can look across some data sets that have been collected at harvest or over long scales for capture operations. And these are some data that come from a long-term partnership between the East Foundation and the Cesar Claiborne Wildlife Research Institute, where we catch hundreds of deer every year across their 4 ranches in the fall. And one of the metrics that we collect is lactation. So is there evidence of lactation at harvest or not? A binary response variable. And then we predict that across this rainfall index, the drier years versus wetter years. And what we see is the probability of observing lactation increases. In fact, it over doubles across this index. So in incredibly dry years, you have a very low probability of lactation. In wet years, you have a much higher probability of lactation. However, even in the high years, you only see approximately 40% of the does with evidence of lactation. Now, some of that is a detection issue where we know the doe did in fact breed and pulled off a fawn and is no longer lactating or has no evidence of it. While some of it is, there are a lot of fawns that aren't making it to this point, and we do not see evidence of lactation. So we're trying to better understand how factors influence that survival probability. So we're partnering with the East Foundation to do just that, a more intensive study where we can actually look at the drivers of fawn survival. And what's so fortunate about doing this with our partners at East Foundation is that they have the San Antonio Viejo Ranch, which has no supplemental feed and no harvest, which can both be confounding factors when thinking about the impact of environmental conditions on deer populations. So here we're able to look at how deer populations respond to precipitation without the buffers that are provided by supplemental feed. And by working in a system like this, this will let us better understand how some of these management actions, like providing supplemental feed, are buffering populations from extreme highs and lows associated with this incredibly dynamic landscape in South Texas. Now, many of you may be wondering, why are we talking about growing more deer when I have to do all I can every year to shoot as many does as possible to keep a lid on the population? Well, I would argue if you want more deer, you should be focused on managing your fawns and does. But if you want better deer, you should also think critically about managing your fawns and does. There's an increasing amount of evidence that factors experienced early in life, gestation and early life stages, can have strong effects on the lifetime body design for animals. And so this is also true for humans. And an example that resonates with me comes from the biomedical literature that demonstrated that during the Dutch famine in World War II, children that were less than 2 years old during that famine were significantly shorter at adulthood than other cohorts, in spite of the fact that they returned to a nutritious diet shortly thereafter. There are these permanent effects from the life experiences early in life. And so you want your fawns and your does to experience life conditions where things are good, and they will have a body design that ultimately will allow them to be bigger and bigger antlered later in life. And so we looked at this with about 30 years of data from harvested animals in Virginia. And again, the acorn crop digestible energy was incredibly predictive and important for body size of bucks. However, the surprising part was the acorn crop experienced by their mother during gestation was more predictive of adult body size than the acorn crop experienced during their first year of life or even the year they were harvested, demonstrating the importance of these early life conditions. So whether you're growing more deer or better deer, it's important to manage your does and fawns. And when we think about managing fawns in the survival process in South Texas, part of what we're hoping to better understand is how long linear features such as right-of-ways, utility right-of-ways, or brush control influence the survival process and the capabilities of fawns to hide from their predators. And so we hope that our research can better explain how landscape configuration in South Texas influence fawn survival processes. So some concluding thoughts: fawn survival is highly variable in South Texas, and it's going to be. Rainfall is going to drive that process. And then supplemental feed may buffer that, but it is no replacement for rain. And finally, early life conditions are important for both the quality and the quantity of your deer. So remember to manage those does and fawns. If there's any questions, I would be happy to address them. My contact information can be found below.